What if your stillness hides cosmic motion? Watch. It is a quiet evening. You are sitting perfectly still in your favorite chair. You feel the solid ground beneath your feet. The air is calm. Everything seems to be at rest. But is it? Imagine a single coin spinning in the air. While it is spinning, is it heads or tails? It is, in a way, both and neither. It only becomes one or the other when it lands. This is a simple way to think about a profound quantum idea called superposition. At the tiniest scales of reality, a particle like an electron can exist in multiple states at once. It can be in many locations simultaneously. It can have multiple energy levels at the same time. It is not in one definite state until we measure it. The very act of looking at it, of interacting with it, forces it to choose one reality from a haze of possibilities. The universe at its core seems to live in a state of potential. Consider light. Is it a wave, like a ripple, spreading across a pond? Or is it a particle, like a tiny bullet fired from a gun? The astonishing answer is that it is both. This is called wave-particle duality. When we are not looking, light travels and interferes with itself exactly like a wave. But when we try to detect it, to catch it in the act, it always arrives as a discrete particle, a single packet of energy called a photon. An object can be a spread-out wave and a localized particle. It depends entirely on how you ask the question. The things we see and touch feel so solid. A table is a table, a rock is a rock. But modern physics has peeled back this surface layer of certainty. It has revealed a world beneath that is far stranger, more fluid, more connected, more mysterious. It is a place where common sense begins to fail us, where the rules we learned in school begin to bend and sometimes to break completely. Our minds are built for the world we can see. We understand how a ball flies through the air. We know that an object is in one place at one time. We expect time to march forward at a steady, reliable pace for everyone. These are the intuitions that have kept us safe. They have helped us build our civilizations. But they are approximations, like a map that only shows the major highways, but leaves out the winding country roads and hidden pathways. Physics invites us to explore those hidden paths. It asks us to be brave. It asks us to set aside what we think we know, just for a moment, and gaze into the deep. The ideas we will explore can feel unsettling. They challenge our very sense of self and our place in the cosmos. They tell us that solid matter is mostly empty space, suggest that time can slow down, and show us that a particle can be in many places at once. We think of time as a universal constant. A second is a second, everywhere and for everyone. It flows like a great unstoppable river, carrying us all along at the same speed. But a young Albert Einstein, with a simple thought experiment, shattered this idea forever. He imagined what it would be like to ride on a beam of light. This led him to his theory of special relativity. One of its most mind-bending conclusions is that time is not absolute. It is relative. The faster you move through space, the slower you move through time. This is known as time dilation. It is not a trick of perception, it is a physical reality. Imagine two twins. One stays on Earth, the other travels in a spaceship at nearly the speed of light. When the travelling twin returns, they will be younger than the twin who remained behind. For the astronaut, only a few years might have passed. For the person on Earth, decades could have gone by. The GPS satellites orbiting our planet must constantly adjust their clocks, Without correcting for this relativistic effect, your GPS would become inaccurate by several miles every single day. Einstein offered a revolutionary new picture. Gravity is not a force at all. Space and time are woven into a single four-dimensional fabric, space-time. Massive objects bend and warp the fabric of space-time. Like a bowling ball on a stretched sheet, paths curve toward mass. The Earth is not pulling you down, it is curving space-time around you, and your body follows the straightest path through that curve. Look out into the blackness between the stars. It appears to be the definition of nothingness. A perfect vacuum. Empty, cold, dark. But quantum mechanics tells a different story. There is no such thing as true emptiness. What we perceive as a vacuum is a seething, bubbling cauldron of activity, the quantum vacuum. For fleeting moments, pairs of virtual particles can briefly burst into existence from nothing and then annihilate. This is not just a wild theory. Its effects have been measured. The Casimir effect pushes two uncharged plates together in a vacuum. Fewer modes within than without. The imbalance nudges them together. Nothingness, it turns out, has substance. Before quantum mechanics, many believed in a deterministic, clockwork universe. Quantum theory adds pure, uncaused chance. When a radioactive atom will decay is fundamentally unknowable. We can predict probabilities for many, but not the exact moment for one. This isn't hidden information. It's intrinsic randomness. The universe has a degree of freedom. It plays dice. The future is not entirely written. There are forks in the road at the deepest level. A long, improbable winning streak brought us here. Deep in space, there are monsters, black holes, regions where gravity is so powerful that nothing, not even light, can escape. At their boundary lies the event horizon, a point of no return. Cross it, and all paths lead inward. Your future becomes a location, not a time. Our theories predict a singularity, where laws break and curvature diverges, a signpost that our understanding is incomplete. There is one more quantum mystery Einstein famously called spooky action at a distance. It is an idea called quantum entanglement, two particles intrinsically linked. Measure one particle's property and you'll instantly know its partners. It's as if they communicate faster than light. Imagine magical coins. Your friend's lands heads on the far side of the galaxy. In that instant, yours is tails. Experiment after experiment has confirmed this spooky connection. The universe is non-local, woven with invisible threads. Quantum laws govern bizarre particles, and they shape the macroscopic world. The structure of the entire universe, the distribution of galaxies and clusters, traces back to tiny random quantum fluctuations in the first moments after the Big Bang. The largest structures we see are fossils of the quantum world, magnified across billions of light years and years. The quantum vacuum may even source dark energy, driving cosmic acceleration. The rules that make an electron act as wave and particle also sculpted the cosmic web. We began with a simple paradox, the stillness that is also in motion. We have journeyed through particles in many places at once. Time that slows, empty space full of energy, and spooky connections that defy distance. The payoff for embracing strangeness is wonder and powerful tools, GPS, quantum computers. The universe does not owe us simplicity, it offers mystery.